In this lesson, we continue to learn about the basics of descriptive statistics, including displaying numerical data and understanding its distribution shape. We will focus on histograms of interval, ratio data. Histograms are different from bar graphs. Histograms are used for interval or ratio level data where the values are on a continuum. See how the bars touch in a histogram? So, it's not a category like we had in the last lesson. The values all run together because you have continuous data here. So, that's what typically goes in a histogram, interval or ratio quantitative data. Once you have interval or ratio data graphed into a histogram, you can examine the shape of the distribution. This includes describing the dataset in terms of its modality, symmetry, and skewness. Modality refers to the number of peaks, or modes, in a distribution. A distribution can be unimodal, which means it has one peak, bimodal, which means it has two peaks, or multimodal, which means it has three or more peaks. Modality is an important concept in statistics because it can tell us about the underlying structure of the data. This can help us to identify outliers or unusual data points. Symmetry in a distribution refers to whether the distribution is evenly balanced around the central point. A perfectly symmetrical distribution would be balanced around the mean or average value of the data. However, many distributions are not perfectly symmetrical. They can be skewed to the left or to the right. A distribution that is skewed to the left has a long tail on the left side of the central point, while a distribution that is skewed to the right has a long tail on the right side of the central point. The skewness index is a measure of the degree of skewness in a distribution. It is a standardized measure that compares the mean, median, and mode of a distribution. A positive skewness index indicates a distribution that is skewed to the right, while a negative skewness index indicates a distribution that is skewed to the left. A positively skewed distribution is one in which the tail on the right side of the peak is longer than the tail on the left side of the peak. This indicates that the dataset has some high values that are far away from the center of the data. For example, the salaries of CEOs of top companies can be positively skewed. A positively skewed distribution is one in which the tail on the left side of the peak is longer than the tail on the right side of the peak. This indicates that the dataset has some low values that are far away from the center of the data. Kurtosis refers to the shape of the distribution in the tails. A leptokurtic distribution has a higher peak and fatter tails than a normal distribution, while a platykurtic distribution has a lower peak and thinner tails than a normal distribution. A mesokurtic distribution has the same shape as a normal distribution, neither extremely peaked or flat. Just like for the skewness, there is an index value of kurtosis that is calculated by computer software like StatCrunch. These values further describe the shape of the data. Finally, the normal distribution is a theoretical distribution that is often used in statistical analysis. It is a symmetrical distribution that is characterized by its mean and standard deviation that we will study in more detail in the next module. As we will see later in the course, the normal distribution is used to evaluate inferences we can make about our data. Many natural phenomena, such as height and weight, follow a normal distribution, and it is often used as a benchmark for comparing other distributions. Now that we have seen the multiple ways of tabulating and displaying different kinds of frequency data, we can see how it can be used to better understand the subjects and their associated data points in our sample. We can now answer purely descriptive research questions. With an understanding of descriptive statistics, we can go on to conduct hypothesis tests and make inferences about a population based on a sample. For example, the frequency of a particular characteristic in a sample can be used to estimate the frequency of that characteristic in the population. We will see this later in the course. For interval and ratio data, making a frequency distribution and a histogram is easily done in StatCrunch. Once you have the data in StatCrunch, go to the Tables tab under the Stat menu and select Frequency. A dialog box will open, and there you can select the variable and the frequency output or outputs. To make a histogram, simply click on the Graphics tab and select Histogram. StatCrunch will automatically bin the outputs for you, but you can change the bins in the dialog box if you wish to. As with all the results and graphs in StatCrunch, you can change the font size or the number of digits by clicking on the Edit tab. and then selecting Display Precision or Fonts to make updates. OK. Let's do an example of analyzing frequency data for a continuous ratio variable by looking at pertussis case rate data in California. Here we have 33 rates to graph and evaluate the distribution in terms of its skewness and kurtosis. Once the data is loaded into StatCrunch, begin by creating a frequency distribution. Again, to do that, go to the Tables tab under the Stat menu and select Frequency. The Frequency Table dialog box will open, and there you can select the rate variable and the frequency outputs, frequency, relative frequency, and the cumulative relative frequency. We have ratio level data here, so the cumulative frequency is informative. To make multiple selections, we hold down the Control key. StatCrunch will then create the frequency table for you. Notice that the software gives you a warning that it will bin all the frequency data here, as we many values that have a wide range. Click OK and StatCrunch will create the table. The table should look like the table from the lecture notes, Figure 6. That table was blood pressure data. Our table here shows that this data has many data points in the low rate range, 0 to 20. Infection rates across the state appear low. Remember that you can lower the significant digits to make your table more readable by clicking on the Edit tab. Then select Display Precision and lower the digits. Go back to your table. Click on the Options box, select Refresh, and the table will update with a change of digits, so you don't have to go through all the table making steps again. Then you can copy and paste the result into any document and edit it there some more if you wish. Again, to make a histogram, simply click on the Graph tab and select Histogram. The histogram dialog box will open, and there you can select the rate variable again. StatCrunch will automatically bin the outputs for you, but you can change the bins in the dialog box if you wish to. In this dialog box, you can make selections to display the mean and median, and you can even overlay a normal curve if you wish. As with all the results and graphs in StatCrunch, you can change the dialog box selections by clicking on the Options button of the graph to make updates. By selecting Edit, then simply click on the Compute button when you are done. One can change the bin width, change the title of the graph, and display or not display other graph items. What is the skewness here? Well, looking at the histogram, we see lots of data trailing off to the right, so this one is positively skewed, right? We can verify this by looking at the summary statistics in StatCrunch from the Stat tab and columns. Then, in the Summary Stats dialog box, we select our variable, rate, and then select the skewness from the statistics area. Here we have to scroll down in the dialog box area to find skewness. Select it and click Compute. The software returns a positive skewness result here, further confirming our result. For the kurtosis, we can see that we have a sharp peak in the data in the 0 to 20 range. That tells us the data distribution shape is leptokurtic. Right? We can verify this by looking at the summary statistics in StatCrunch in the same way we did for the skewness. Click on the Options box, then Edit to bring up the Summary Stats dialog box, and now select the kurtosis. We get a positive number here, further confirming that our data is leptokurtic. Let's do another frequency data example using a larger data set. The frequency distribution of the weight of the participants in a hypertension study that we will analyze for this module's assignment. Let's examine the distribution of the weight of the participants in the study. Again, once the data is loaded into StatCrunch, begin by creating a frequency distribution. Go to the Tables tab under the Stat menu and select Frequency. The Frequency Table dialog box will open, and there you can select the weight variable from all the list of variables in this data set. Then select the frequency outputs, frequency, relative frequency, and the cumulative relative frequency. Again, here we have interval, ratio level data. So the cumulative frequency is informative, we will select it here to display in our table. StatCrunch will then create the frequency table for you. Our table here shows that this data has many data points in the 150 to 200 weight range. To make a histogram, simply click on the Graph tab and select Histogram. The histogram dialog box will open, and there you can select the weight variable again. Click Compute and StatCrunch will automatically create a binned histogram for you as we have a wide range of values here for weight. What is the skewness here? Well, looking at the histogram, we see data points trailing off to the right. So this one is positively skewed, correct? For the kurtosis, we can see that we have a peak in the data in the 150 to 200 range. That tells us the data distribution shape is leptokurtic, right? Again, we can verify this by looking at the summary statistics. From the Stat tab, select Summary Stats, and then Columns. Then, in the Summary Stats dialog box, we select our variable, weight, and then select the skewness and kurtosis from the Statistics area of the dialog box. Click Compute. The software returns a positive value for the skewness and kurtosis here, further confirming our result from looking at the histogram. Frequency data is a fundamental tool in statistical analysis, providing insights into the characteristics of a dataset and helping researchers draw conclusions and make informed decisions based on the data. In the next module, we will look at even more aspects of descriptive statistics and more complex graphing as we continue to build our skills at analyzing and making sense out of data.